Friends, please remember on this channel I post math videos, usually of a more advanced or a non-routine or a bit more interesting nature. So here we have a nice question in vector analysis. Given vectors a and b, and denoting the magnitude of a as just a and the magnitude of b as b, show that this new vector, c defined as ba plus ab, bisects the angle between the vectors a and b. So that's our goal here. Okay, so we got to think then, since we are asking about angles, we have to be thinking about cosines usually and such. So let's do that. As a reminder, some of the tools that we will need here. Remember that a dotted with a, so that would be, say, for example, like a1 and then a2 dotted with a1 and then a2 this way. That's a common tool. So now if you go through this, it would be a1 squared plus a2 squared, but that's just equivalent to basically the square of the magnitude of the vector. Well, in this case, we're using this notation, which again, remember the magnitude of a, we are just indicating by writing little a, so it's a squared. Okay, we should know that. We'll use it here. Now that tool's in place. So next, look, let's remind ourselves of cosines. So the cosine of an angle, we'll call it theta 1 for now, like that. We can define this quantity as a dotted with c, and then divided by the magnitude of a and the magnitude of c this way. Now, why do we need theta 1? Because this vector here, ba plus ab, we're imagining it basically doing something like this in terms of a picture. Let's say we have maybe a going this way and b going this way. So let's say c is going this way, okay? We can't assume at first that it's splitting this angle into equal pieces, so just keep that in mind. But it does mean that we have at least theta 1, and then here we're going to have theta 2. So call this a, call this b, and then call this c. We're going to show that this is equal to this. Okay. So now let's work through this. Our vector a is just that. It's just a, correct? And then you're going to dot it with c, but c has a specific form up there that says ba, like this, plus AB, like that. And then the bottom, we can use, for the magnitude of A here, just A, and that one will stay as just this. Okay, let's work through this expression here. Okay, so let's work through this. Distribute this over. So take this constant B right here, and you can just pull it out. So you're going to have B, and then you're going to have A dotted with A this way. And then you're going to take this vector a distributed over to here. So in that case, you're going to have this constant a right here, which is the magnitude of a. And then you're going to have a dotted with b. And this is still over a and then c this way. Okay, remember, like this quantity right there, a dotted with a, if you look over here very carefully, right, that's just a squared. So that means we can say the following at the next stage to finish this up all the way on the right side here. We're going to have v a squared basically plus a, and then a b this way, the vector is there, and then this is hanging over a c this way. Of course, now what we can do is just factor. So let's do that next. So where are we here? Factor, cancel, cancel, then cancel. So all that remains, in fact, as you can see there, let me stress it, right, is this b with a single a plus the vector a dotted with the vector b over the magnitude of c this way, right? That's what remains. So let's see whether for the second angle we get the same expression or not. That's all that really matters in the end. So I'll begin all the way over here. So cosine of theta 2. So same logic would apply. Let's say it's this angle right here. Let me draw the picture back quickly. Remember, so if this is A and this is B and this is, say, C somewhere like this. Okay, so A, B. Yep, B is right here. Then let's look at what happens with theta 2, which is that angle, say, between them. Okay. Okay. So When we do that part, we're going to get the following. B dotted with C, like that, and then over the magnitude of B multiplied by the magnitude of C. So go through this. So B dotted with C, just apply exactly the same steps essentially. You're going to have B dotted with that vector C, which is BA, let's see, plus AB. And this is hanging over the magnitude of these two, but remember, this is just B the way we have our notation. So it's basically just B times the magnitude of C, and then go through that. So distribute this and all that, rearrange terms a little bit. So it's going to be B dotted with A, and then this constant B out front. So it's going to be B, and then the vector A dotted with the vector B. Same thing over here is going to be B dotted with AB. So you're going to end up with the A out front. That's a constant scalar. And then B dotted with this B will give us this, correct? Right here. So B dotted with B, same vector. And then this is hanging over B, multiplying the magnitude of C this way. So now, what happens? Well, just like A dotted with A is A squared, and B dotted with B is just B squared. The magnitude, that is. So you're going to have, in other words, B, A dotted with B. So these are dot products here, right? And this is B with an arrow above it for the vector. Okay, let me grab more chalk here. So now, for the other one, I'm going to have plus A, and then replace this basically with B squared. And this is hanging over B times C. And now, of course, what do we do? Well, okay, so cancel this, and then cancel this. So that means at the very end, what we have left over is A dotted with B. So A dotted with B, like this, plus this A, B, hanging over the magnitude of C. But now, take a look. Whatever expression we had left over here, right, whatever this expression was, now this is exactly the same expression term by term, correct? So we had, in other words, the magnitudes of A and B. We have the magnitude BA, whatever, the same thing. Then you have A dotted with B, A dotted with B, and the magnitude of C and magnitude of C. That means these expressions are identical. So the only conclusion we can reach, therefore, based on all of this, lastly, is that the following is true, that cosine of theta 1 is equal to cosine of theta 2, which of course then implies that theta 1 equals theta 2, which answers our question. In other words, we would say that, look, the angle between A and B is bisected, since these angles are the same. So theta 2 equals theta 1, which means the angle is bisected between A and B right here, that angle. That is it for this one. Please be sure to subscribe and like if you're into math videos of a more advanced or non-routine or interesting nature.